In computer science, a queue is a collection of elements that are maintained in a particular sequence. And these sequence can be modified by addition of elements at one end of the sequence and the removal of elements from the other end of the sequence. So this is an illustration of what a queue looks like. Similar to a long line of people inside a supermarket, in Costco, Disneyland, queue in general, this data structure maintains what we call first in, first out structure. Queue in computer science is an ADT, abstract data type. This is not a collection. You can use collection to implement queues. There are different ways, different collections that you can use to implement it. But queue specifies a couple of things. The ability for you to add people to the end of the line, the ability for you to remove people once they're done by manipulating the elements inside this sequence in that order. There are two transformers or modifiers in queue. One of them is called enqueue, and the other one is called dequeue. Enqueue means that you're adding an element to this collection, whichever underlying collection is for the queue interface. Dequeue means removing it. So just remember that when you add a element, you're adding at the end of the queue because this is first in, first out. And when you remove the elements, you are removing the front of the element. Pay attention to the word enqueue and the word dequeue. In some contexts, and it depends on which collection you're using. For example, if you use stack, array stack to implement queue, when that happens, enqueue is called add. In some instances, it's called push, as you know from our previous lecture. And dequeue becomes a pop operation using stack. This is an example of Java API, SE11, JDK 11. The queue here is the interface. So this is a generic interfaces that could be implemented in a variety of different ways. You see some concrete classes that are being implemented. For example, the array dequeue here, this is frequently used queuing structure that dynamically resizes itself using array as the underlying collections to build it. You'll see in the Java implementation, it's named as far as the queue methods or transformer goes, add and remove. You also have pull and peek. So these are read-only operations. It depends on which language that you're using. The queue interface in general, they all have the enqueue, dequeue terminologies to refer to the addition and removal of the elements. Some of the languages, they may have different name methods, signatures to specify the enqueue and dequeues. As you'll see in our queue implementation, there is a new constructor that we utilize to create an empty queue from the start. So these are the operations that you typically see. And there's also peek as well as remove and clear, which allows you to clear the entire underlying collections inside a queue. The most important thing that we want to pay attention to is enqueue and dequeue. So let's take a look at the very next one. This is a visual representation of what a queue is at work. So what you see here is an empty queue from the very start. In general, you want to have two pointers that tracks the operation inside a queue. One of them is called front and the other one is rear. So front refers to the very first element inside the list. The front of this queuing structure is always fixed. However, the rear, this is the pointer that points to the end of the queue, changes all the time. When you remove an element from the queue, first in, first out, your front changes as well. In the beginning, when the queue is empty, you have nothing. What we do in that case is to set both front and the rear to a value of 0. Whether you want to have it both variables initialized to a number like -1 or some generic numeric, it's totally up to you. As we slot a element into it, your front becomes block 2 and rear is block 2 because both front and rear, they occupy the same space. And as you move more blocks into it, like say block 3, your rear becomes your block 3, and then your front stay the same. And this is for enqueuing block 2, block 3, 2 and 3, and then block 5, your rear becomes 5. Your front is still pointing to 2. So when you dequeue, what happens? The first element is going to get out of it, right? So dequeue means dequeue this entire 2 out of the space. Your front moves to what's available, which is 3, because 2 is out already. Your rear is still pointing to 5. We're going to enqueue 4. So if 4 comes in, then your front stays the same, but your rear auto increments to the very next block from 5 to 4. This is what happened to enqueue and dequeue in general. You're going to see a lot of applications of queues in computer science, especially in concurrent environments where you have multiple requests and responses from concurrent users. When that happens, queues generally used to throttle high traffic when all of the requests are hitting this particular database or maybe services. They're coming from all kinds of directions. You have only one resource here. And this resource could be a DB, could be a in-memory cache, or a service that takes these outside requests coming in at the same time. In order to throttle, to slow down, or to make sure that the information are in the order they're received, we set up what's called queue to throttle their information. This one is queue. Request comes in, first in, first out, store inside the queue, and you can have another thread to send this request based on the order they're received into these resources. And this is to allow some breathing room for this underlying resources not to get overwhelmed all of a sudden by 10,000 concurrent requests coming in. There is a throttle. You also see lots of queues used in real world software. One example is ATM machines. When transaction comes in from you or maybe from your family members who happen to have financial transactions, those transactions need to be queued up. Whoever comes first would be evaluated in terms of what that transaction is. This is a brief introduction on what a queue is.